All right, just a quick walkthrough on the activity, correlation, and regression for periodic data. So what you're going to do is collect data, average temperatures in degrees, uh, for or for a location, capital city that you randomly select, and a randomly selected year. So you go to Schoology and use the randomizer to come up with those values. All right. So I did it once. Came up with Albany in 2023. So what I did was I then went to WeatherSpark, gives a redirect, type in Albany, New York, and you can see the climate history. If you click on the year and then go to averages, you see you get a raw list of high temperatures. All right, that's what we're looking for. So I'll just copy that, bring it in. All right, so I'm going to do a paste special, values only. It's organized horizontally, which I don't like. All right, so I'm going to organize it vertically. So I'm going to highlight the values, copy, and then just somewhere off on the side, edit, paste special, this time transposed. So transpose takes a row-oriented set of data and makes it column-oriented, so vertical. So I'm going to pop this in, and I'm going to get rid of all this stuff now because I don't need it anymore. So now I have the data, but Google Sheets is going to kind of flip out if it sees values that are a concatenation of characters and numbers. So we just change these to numbers. So quick overwrite: 32, 36, 45, 59, 70, 78, 82, 80, 72, 60, 48, 37. So I'm going to create a scatter plot. I'm also going to center this, make it look a little nicer. All right, so grab this guy, center it up, and highlight, insert chart. It labeled it nicely for us. I'm going to change the title, Albany in 2023. Resize, pop that in over here where it says insert scatter plot. All right. For the rest of the assignment, we actually have to go to Desmos. Right? To do a cubic regression is possible in Google Sheets. It's just not as user-friendly. But for a sinusoidal regression, it's too problematic to try to do it in Google Sheets, so we don't even bother. So we'll do everything in Desmos. So I'm going to go to desmos.com. You may have to create an account, but odds are if you've come this far, you probably already have one. Math Tools Graphing Calculator, or you could just hit Open Graphing Calculator. What I'm going to do is I'm going to copy my data, just the data points, not the titles. I'm going to pop it in. If I copy 2 columns at a time, when I paste it in, Desmos assumes that I'm trying to copy a table, so it puts it in table form. All right. So that corresponds pretty nicely with the scatter plot that we had generated in Google Sheets. So let's go with linear regression first. So Desmos can handle pretty much any regression model as long as you type it in correctly. So for a linear, I'm going to put quotes here, linear, it's in the form of y1 tilde, a plus b x1. And the reason they're x1 and y1 is because those are the column headings for the table. So if I type that in, y1 tilde a plus b x1, then I have the line that best fits the data, and you can tell by this that that's not a good fit at all, right? I have the r squared value, which justifies that, so it's really not a good fit. All right, so r squared value, just paste that right in. Do I see a pattern in the residual plot? Well, I haven't looked at the residual plot. So right under where it says residuals, click plot, and it'll make the residual plot. Right, so we could turn off everything else if we want, just turn off all this stuff with the line if we don't want it. This one too, and just look at the residual plot, or we could just leave it all on. Right, it really doesn't make a difference in terms of what we're trying to accomplish here. As long as you can look at this one and recognize that it's a scatter plot, and this one recognize that it's a residual plot, you're good. All right, so you save it. I'm going to save it as linear. When you hit save, should lock it in, and you can go over to the share icon, copy the link. That's what you're going to put into Google Sheets. So I'm just going to paste that right in. Now, I might do some respacing, but that's okay. All right, now I saw a pattern in the residual plot, so I'm going to select yes. The model is likely not appropriate, so we're good. So we know, we kind of knew off the jump here that we weren't going with a linear model just based off the shape of the scatter plot, but it's nice to have the numerical values to back it up. All right, so now what I'm going to do, instead of a linear regression, I'm going to try a cubic regression. The new update to Desmos gives a drop down that allows you to change up your models, which is really nice. All right, it'll give you the model and it'll give you the R squared value. All right, so if you didn't have that, that's fine. I'm gonna type in the model anyway. So if I type in cubic, that's going to be y equals a plus ax cubed plus b x squared plus c x plus d. So I can type it in that way, but the x's are all x1. So a x1 squared cubed, sorry, plus b x2 squared plus c. Sorry, x1 all along, not x2, squared plus d. And I'll just wipe this out and just show you. All right, so I'm going to leave this at linear and just kind of pretend that I didn't recognize that. So when we do this, I'm going to delete the regression just so we're kind of taking it from scratch here. I'm going to type in y1 tilde, not equals, a x1 to the third power. If you hit the little caret symbol, that's shift 6, that raises it to a power, plus b x1, raise it to a power, plus c x1, raise it to a power. Well, in this case you don't have to because it's to the first power, plus d. And you see it's a pretty good fit. We have an R squared of 0.9567. We'll look at the residual plot. I see a pattern there, right? So for my cubic, even though it seems to fit most of the points, I still see a pattern, so it tells me that the model is probably not appropriate. All right, so what I'm going to do is I'll save this. I'll save it and rename it as cubic. Create a new share link and paste it right in here where it says Desmos link. Again, it might do some reorienting. Now, just going back, what I did was I clicked on the link that I created for the linear model, and you see it brought me to the linear model. All right, so it'll bring you to, when you create a share link, it's a static link. It brings you to what your settings were the very last time you actually saved. All right, so you don't have to worry about losing your stuff once you create a share link. All right, and if I go here, click on this one, same idea. This is my cubic. All right, so as long as everything's looking the way you want it to, you're in good shape. All right, so now what I'm going to do is a sinusoidal model. I'll save it as sinusoidal. All right, you can wipe out a lot of this stuff We don't need that anymore, we don't need that anymore, all right? So my model here is y1 tilde a sine bx1 plus c plus d. So I'm going to type that in, y1 tilde a sine parentheses bx1 plus c plus d. And you don't really have to be overly familiar with trig functions in order to understand this. This is the model. It's giving us the coefficients that make that model appropriate. You might remember something about amplitudes and frequencies and things of that nature, but for our purposes, we're just looking for an equation that fits it very well, and that's what we have here. So I got my r squared value. I'm going to copy that in. Residual plot, take a quick look. Plot, I'm not seeing really anything in terms of a pattern, but if I zoom in, you see that little magnifying glass? It'll bring it in pretty good, and you can see here that it's scattered seemingly randomly all over the place, so we're in good shape. Hit the little back arrow there to undo, so you bring it right back to the appropriate frame there. All right, so I do not see a pattern, so that tells me that this model is most likely appropriate. Let me grab that link. All right, so again, I could save it, create the share link, copy, paste it in, double check by clicking on it, and you can see it brings me right back. So we're in good shape. The most appropriate model after all this would be the sinusoidal, has the best r squared value and no pattern in the residual plot. All right, so what we have here is another tool that'll help us to analyze bivariate data. So you just kind of think of this as yet another calculator that we created. All right, and if you don't like the spacing, you can always change the settings, format, instead of wrapping it, let it overflow, and that'll kind of clean things up. Oh, I hit the wrong thing. Where did I go? All right, so I'm on my cell here, format, wrapping, overflow. The one on the bottom, I guess I don't care about as much, but I'll do it again anyway. Format, wrapping, overflow. Now it's kind of a nicer looking page here. All right, so if you follow these instructions, this process with your own state capital and your own year, the one you randomly selected, and I verify, then you're going to be good to go.